We'll start by introducing our topic, which is about LIMS implementation and configuration. Our goal is to tailor these systems effectively, ensuring they lead to excellent laboratory operations. We'll discuss the key objectives behind using multiple LIMS environments in a laboratory setting. This strategy is crucial for ensuring safety, maintaining compliance, and boosting overall operational efficiency. One primary objective is effective risk mitigation, protecting your valuable laboratory data. This helps prevent any untested modifications from potentially corrupting your critical production data. Another vital objective is ensuring thorough validation assurance for all your processes. This ensures that all workflows are fully compliant with regulations before they become operational. Multiple environments also greatly assist with training and onboarding new staff members. They provide realistic, hands-on environments where staff can practice and learn effectively. Finally, these environments enable a very controlled deployment of system changes. This facilitates a phased rollout of new features, ensuring a smooth transition without disruption. We'll now explore customization within LIMS, a key aspect of tailoring the system. The main purpose is to tailor the system precisely to meet the unique needs of each laboratory. Let's define customization in the context of laboratory information management systems. It refers to any modification made to adapt the LIMS to your lab's specific requirements. Customization can range from simple configuration adjustments to more complex underlying code changes. The first level, configuration, is considered a relatively low-risk form of customization. This involves adjusting system settings and creating various templates to streamline operations. It allows you to easily define and standardize your laboratory workflows without extensive coding. Next, we have extension, which carries a medium level of risk for your system. This includes adding custom fields, creating dashboards, and developing user-defined reports for specific data. Extensions enhance system functionality significantly without altering the core LIMS software. Finally, code customization represents the highest risk level for your LIMS. This involves directly modifying the system's underlying code or changing its database structure. Such changes require extremely careful development, thorough testing, and robust validation processes. Let's now discuss the potential risks associated with over-customization in your LIMS. Understanding these pitfalls is crucial for making informed decisions about LIMS modifications. We'll examine several key risks that can arise from excessive customization. Over-customization often leads to significant difficulties when it's time to upgrade your system. Each customization adds to the validation burden, requiring extensive testing and documentation. You'll also face higher maintenance costs due to the need for specialized ongoing developer support. Furthermore, vendors may limit or even withdraw support for heavily modified LIMS systems. Now, let's consider the specific impact of each of these risks on your operations. Vendor patches intended for standard systems can easily break your custom code. Remember, every single customization you implement must undergo rigorous validation. High maintenance costs stem from the continuous need for specialized developer support. This means vendors might not assist if your system encounters issues after modification. We'll now delve into the various LIMS integration types and the different approaches you can take. The primary goal is to connect disparate systems, ensuring a seamless and efficient data flow. Let's first explore the different categories of integrations commonly found in laboratories. This involves integrating laboratory instruments like HPLC, GC, balances, and spectrometers directly with LIMS. Next is integration with enterprise systems such as ERP, MES, and PLM for broader data exchange. We also integrate with scientific data systems including ELN, SDMS, and CDS platforms. Finally, integration extends to external stakeholders like contract labs and for regulatory submissions. Now, let's discuss the various approaches used to achieve these system integrations. A point-to-point approach involves a direct, dedicated connection established between just two systems. Middleware-based integration uses an intermediary software to standardize and manage communication between systems. The API-based approach is a modern method using either REST or SOAP. APIs for flexible connectivity. We'll now outline a standard operating procedure or SOP for managing customization and integration efforts. The first step involves thoroughly gathering all the requirements for your customization or integration. Next, perform a comprehensive impact assessment to understand potential risks and benefits. Then, carefully design the solution and thoroughly document all aspects of your plan. Following design, you'll develop the necessary components and configure the system accordingly. After development, rigorous testing and validation are essential to ensure everything works correctly. Finally, deploy the changes to production and establish a plan for ongoing maintenance. Let's examine the crucial testing and validation phases for LIMS workflows. These phases are essential for ensuring both system reliability and full regulatory compliance. The first phase is installation qualification, often referred to as IQ. IQ verifies that the LIMS has been installed correctly and according to its specifications. Next is operational qualification or OQ, which evaluates system functionality. OQ verifies that the system operates exactly as intended under various defined conditions. The final phase is performance qualification, known as PQ. PQ verifies that the system consistently performs reliably under actual, real-world operating scenarios. We'll now cover the SOP for configuring user roles and permissions in LIMS. This SOP is vital for establishing secure and compliant access control within your system. The process begins with defining user roles and obtaining the necessary approvals. First, clearly identify all the distinct functions performed within your laboratory. Then, map these identified functions directly to specific user responsibilities. Carefully define each role's description along with its associated permissions and access rights. All defined roles must be formally approved by your QA and IT security teams. This ensures a formal sign-off process is completed before any roles are created in the system. Next, we move to the crucial phase of user account management within LIMS. The process involves efficiently creating new user accounts as needed for personnel. Typically, the HR department initiates the request for new account creation in the system. It's critical to assign the correct predefined role to each new user in LIMS. All role assignments must be carefully conducted with proper authorization and approval. Both the supervisor and QA personnel must approve each role assignment for security. Continuous oversight is essential for maintaining secure and compliant access controls. Regularly perform periodic reviews of all user access rights and permissions within the system. It's a best practice to review all access rights at least once every quarter. These reviews help detect any inactive or unnecessary accounts that might pose a security risk. It's crucial to deactivate user accounts promptly when they are no longer needed. This should happen immediately upon an employee's exit or a change in their role. Let's review the core principles that govern effective access control in LIMS. These principles are fundamental to safeguarding LIMS, data integrity and overall security. The first is the principle of least privilege, often abbreviated as POLP. This means users are granted only the minimum access required to perform their specific job duties. Next is the important principle of segregation of duties, or SOD. This ensures that critical tasks are divided among different roles to prevent potential conflicts. Another key principle is accountability, which is essential for audit trails and security. Every action performed within the system must be linked to a unique user ID. Finally, we have the concept of a clear role hierarchy within the system. This means roles are clearly defined and organized in a structured, logical hierarchy. We compare different LIMS cost models, focusing on capital expenditure versus operational expenditure. Specifically, we'll contrast CAP-EX for on-premise solutions with OPEX for cloud-based systems. Let's examine various aspects that influence the cost and deployment of LIMS. First, consider the initial cost associated with setting up your LIMS. Next, we look at the ongoing maintenance requirements for each deployment model. Scalability is another crucial aspect, determining how easily the system can grow with your needs. We also need to factor in the costs associated with system upgrades and updates. Finally, let's consider the long-term financial implications and total cost of ownership. For on-premise LIMS, the financial model typically involves capital expenditure or CAPEX. Initial costs are high, involving significant investments in physical servers and software licenses. Maintenance is managed by your internal IT team, requiring dedicated resources and expertise. Scalability is often slow and heavily dependent on purchasing and installing new hardware. Upgrades typically incur additional CAPEX, requiring further investment in hardware or software. The long-term total cost of ownership can be higher if the system is not fully utilized. In contrast, cloud LIMS generally follows an operational expenditure or OPEX model. Initial costs are low, primarily consisting of a recurring subscription fee to the vendor. Maintenance is fully managed by the cloud vendor, reducing your internal IT burden. Scalability is rapid and highly flexible, easily adjusting to changing demands as needed. Upgrade costs are typically included within your ongoing subscription fees, offering predictability. Long-term costs are more predictable and often based on your actual usage of the system. Let's now summarize the key takeaways from our discussion on LIMS implementation and configuration. These are essential points for achieving successful LIMS operations in your laboratory. Customization and integration are vital for adapting LIMS to your lab's specific and unique requirements. Utilizing multiple environments such as BEV, STG, and PROD ensures safe and controlled deployment. Rigorous testing and validation processes are absolutely critical for maintaining regulatory compliance. Properly configured user roles and permissions enforce strong data security and accountability within LIMS. Your deployment choice, whether on-premise or cloud, significantly impacts both cost and scalability.